Okay, so today we're going to talk about reading graphs. We've been looking at a lot of graphs. We've looked at the Cartesian plane, learned that it's made up of two number lines, right? We know that the middle where they meet is called the origin. We know that we plot points using ordered pairs. There's an x-axis, a y-axis. We've learned a lot about graphs, right? Well, but there's still some more to think about when you're working with graphs. And one of the reasons why we're going to focus today on reading graphs is so that you can see some of the ways that they're used. Because a lot of times in math, you don't get to really see why you're doing something, right? And so we're going to explore a little bit today about who uses graphs and why they use them and why they're so useful. And it's also going to give us a little more understanding about pieces of the graph and how you can answer questions about the graphs using the right information. Okay? So we're just going to jump right into these. There's very little math to do today. Most of it is about the ideas, the concepts, right? Reading these graphs. So we're just going to jump into Education Perfect and go through these slides. Now, they, of course, go a little slower than you will, but bear with me, because if you don't see every slide, then you don't get to see every kitten either. So, we have our priorities. All right, so here we go with reading graphs. Whoops, let me start with the first slide. That would be helpful. Okay. So today we're going to talk about interpreting and analyzing graphs. What does it mean to interpret something? What's the most common thing that you interpret? Think of something you interpret. Right. Sure. So you interpret what you're seeing like in a piece of art or video? Is that what you're saying? Yeah. Data, so you interpret data and see what the data is telling you about a specific thing. How about languages? Yeah? So you might be saying something in a different language and someone has to interpret it to someone else so that they can understand what you're saying, right? So it's about reading. It's excellent. All those are excellent points. So it's about using the information you give and you're given in a certain way, right? And then being able to present it in another way that everybody can understand. And analyzing. What do you do when you analyze? Why would you want to analyze? What's the purpose? Sure.
To see what's on the graph.
Okay, to see what's on the graph. And it's usually used to make a decision or answer a question, right? So, yeah. So you're going to read the information. Use the information off the graph to be able to answer questions or make decisions, right? So interpreting and analyzing graphs are one of the reasons why we spend so much time with working in this area, okay? So what we're going to do, when you interpret something, you're going to take a closer look about what it actually means. What does a graph mean? Because so far all we have is a line on a piece of paper, right? Well, we want to talk about what they mean and how we can use that information. The first thing that you need to make sure of when you're interpreting or analyzing or reading a graph, we talked about a little bit yesterday, is that you always make sure to watch your units, right? If they're measuring in liters, then your answer must be in liters. Yeah, if you're talking about time, then your answer must be in units of time, either seconds or hours or whatever, right? Depending on the units that are given. And those units have to be given on the graph or the graph is not right. So what should you always do then if you're drawing a graph? You need to?
Make sure that the units are correct.
Exactly. Make sure you're using the correct units. Yeah? So if you're measuring height, for example, then you better say, I'm measuring height in... Can I just say height? Nope, I need to say meters or centimeters or whatever measurement is more appropriate. Probably centimeters, right? Sometimes meters, but height in meters doesn't tell you that much. Okay? Good. And so they also introduce here the idea of authentic data. What do you think authentic data means? That the data is Real, exactly. So, for example, would it be authentic data if I just made up a bunch of heights for all of you in the class and put it on there? No. But what if I measured each one of your heights and then put that on a graph? Yes, that's authentic data. Okay? So it's important that the data is authentic. And you'll see they do all kinds of lengths, distance, measurements. Okay? Another common variable. What does that word mean?
Wasn't it 4 stages?
Pardon me?
Wasn't it like the 4 steps that you gave us?
It's one of those 4 pieces of a term, yes. What does it do, though? Why is it called a variable?
Something that represents something.
It's something that represents something else, but why variable? What's that word?
It can change.
Because it can change, right? So if I was measuring all your heights, are all of you exactly the same height?
No.
So your heights are variables, right? Because they can change. It's going to be different depending on who you do. Now, could you possibly get exactly the same height for 2 different people in this room?
Yes.
You bet. But it's unlikely that everybody's going to be the same, right? So that's why they're called variables.
So you would cause variables if you're measuring the height?
Well, your height would be a variable, right? Okay? So your height would be the variable. And you can measure that. So another common variable that they use is time, right? So are all of you exactly the same age?
No.
Yeah, pretty close to it probably in years, but in days?
Yes,
Yeah.
me and Sophie
So-
are. Yeah, we're 16 hours apart.
Excellent.
We're 2
See?
hours apart.
So- Did you know that if you have a room, this is totally aside, but statistically, if you have a room of 15 or more people, that it's almost 100% likely that 2 people will have the same birthday?
How is that possible?
It's just crazy. It just works. So you can ask. So
5 days in a year.
exactly, but just you can do the study, and it's almost every room of people where there are 15 or more people. It's crazy. So obviously we have 2 hours apart. So there's the same birthday in here, and how many people are there? 18.
We don't have exactly the same day, or she's close.
So it's very
I'm
weird.
27,
Yeah.
she's 28.
Y'all are pretty close. Okay? Sorry. Let's get back to what we're doing here. So scientists, engineers, economists, and other people use graphs and special symbols to represent different units. You've seen some of these. You don't want to write out meters, so we just use M, right? Seconds, S, liters, L, and liters is usually a capital L. Okay? So different letters to stand for different things. Okay? The meters thing kind of messes with you a little bit because what did we say that because we're not talking about using it as a variable, we're talking about using it as an abbreviation. So it can be M. We don't use M as a variable in our equations because M always stands for what thing? Gradient or the slope, right. It's reserved for that special use, right? But these are abbreviations for units, so that's not the same thing, okay? All right. So here are some, just a little list of different ones that you might see. Meters, millimeters, centimeters, seconds, minutes, etc. Now, what you do have to remember, look at the bottom one. The measurement for happiness is kids. Okay. Chocolates, good. All right, but what's important is you use appropriate measurements for what you're measuring. Okay? So, if I'm going to measure all of your heights, I'm going to use kilometers, right?
Yes. I have a kilometer tall.
Why would kilometers be a really rotten measurement for height? Yeah, it's way too big, so you'd get this crazy decimal, right? Okay. All right. What about if I used millimeters? They're too small. So meters would be pretty good, or centimeters might be even better because, right? They're a better measurement for your height. But meters or centimeters, either one of those would probably work better, right? Okay.
1 meter, 60 centimeters.
Right. Well, then that's the beauty of the metric system. It's so easy to convert, right? Okay, and to put the units together. All right. What about if I was going to measure your age? I would naturally measure your age in seconds, right?
No. In years.
In years, exactly. Right? Or if you're very young, sometimes with babies, they measure their age in in months, yeah, or days, something if they're really, or maybe even hours if they're very, very young, right? But do you see that what you're measuring helps determine what units to use? Good. Okay. So take a look at this linear graph. If you look at the x-axis, which one's x-axis? Just anybody, yeah, just the horizontal one at the bottom, right? What about the y-axis? That's the vertical one. Good. And in this particular case, the x-axis is showing what kind of things and in what units. What is it measuring and in what units for the x-axis? Time in hours, right? So do you see you have two things? You have what's being measured and the units. Not one or the other. Right? But both. So, what about the y-axis? What's it measuring? Yeah? It's measuring what now? The volume of the ice cream in what kind of units? In liters. Okay? So, keep that in mind. It's very important that you understand and use the units as you go. Okay? All right? And so also notice at the very top, they have a title for the graph. This is the volume of ice cream eaten over time. If your graph doesn't have a title, your graph is wrong. Because if you don't tell people what it is you're measuring, then the data that you have is worthless. Right? Okay? I'm going to give you all 50. Exactly. 50 ice creams, 50 credits, $50.
Can I have $50?
50 whacks with a stick.
$50.
Yeah. So do you see that? Okay. So do you see that it matters? What you say matters. You have to be very precise. And that's one of the reasons we study mathematics. Do you know that? Were we studying mathematics to make mathematicians out of all of you? No. We study mathematics to make you better thinkers, better thinkers, or make you thinkers and better learners, right? Right. Yes, and we do it a little bit to torture you, of course. It's fun to do, yeah? Okay? All right, so that's your homework. I don't want to go into that one. Let's go into this. So let's look at interpreting graphs. Okay? Well, did I just click too far on there? All right, here we go. So, the position of each point of data on a graph gives you useful information. So, for instance, this graph is talking about the heights of this age of Samson's siblings. What does it mean if you're a sibling? Brothers and sisters, yeah. So here's this family. 1, 2, 3, 4, 5 children in this family. And there's their heights. There are their heights. And then what's the x-axis telling you? Age in years, right. Remember, age in years. So we always want to say that what it's measuring and as well as the units. Okay. Ah, well. Is Horace the tallest?
No.
Look closer. Horace and Marjorie are what? The same height, right? Who's the oldest? Horace, because you get older as you go further to the right. Good job. How tall is Lenore? 100 centimeters. How old is Bertram? 10 years. They do have odd names. So, do you see how much information you can go and how clear it is? Okay? How old is Augustus? 2 potatoes? 2 years, right? We need some units on there. 2 years old. And it's very easy and how organized and nice and neat and clean this is, right? And that's one of the reasons why we use graphs, but it's also one of the reasons why it's so important to be able to read them. Okay? So, right? So, which one of these two, is Oliver and Natalie taller? Oliver's taller because height is measured as the y-axis, so up and down, right? Okay? Is he taller because the dot is higher? No. He's taller because the dot is higher on that scale, right? Yeah. Okay, so be careful. It's not just the tallest dot. Which one is the youngest of the two? Natalie. I don't know. I think that's strange spelling. I don't know. Okay, there we go. And so you see that they're just drawing the lines so that you can compare the heights. And you can certainly do that. You know, y'all, I know most of you are using the writing tool when you're using Education Perfect. Sorry, I almost called it Course Compass. That's what I used back in the States. It's a different program. But that writing tool is great for being able to draw the lines and organize your work and writing dots. Okay? All right. So, Oliver clearly got taller because he's watering himself. I don't get that, but anyway. All right. You know, got to have a little fun. All right, and so now you can see that their age differences and which one is older because it's further on the x-axis, the age thing. Here's where they're talking about the units. I'm 252,460 at 801 seconds old. Is that how you measure your age? No. Okay? And if you want to figure that out, go ahead. All right? Of course, we've got to have ice. There's always a question about ice cream. So, this is the volume of ice cream in the freezer over time. What do you notice about the line? It's decreasing. Why? Because somebody's eating the ice cream. Exactly. So, as you eat the ice cream, it goes down. And so, how much ice cream did we start with? 2 liters. Excellent. And how long did it take until we had no ice cream at all left?
5 hours.
5 hours.
Wait, over 5 hours? Doesn't it usually take like a week?
I'm going to eat 2 liters of ice cream for 5 hours.
Yeah, would you be allowed?
It could have. Hold on, guys. They didn't give us any information to be able to determine that, did they? Is this one person eating this ice cream or is it a birthday party? We don't know, right? We just know some information. So we would like to know more information, wouldn't we? Because it would give us more things to know. Okay? All right. Let's see. So we just did that, how much ice cream there was to start with. And we talked about how long it takes for the ice cream to end. I don't know. It looks disgusting. Okay. All right. So, again, remember, when you start, that's where X is always what number? 0 at the beginning. Good job, guys. We talked about that yesterday. Okay? Anybody know who that is? George Takei from Star Trek. I don't know why he's relevant for you guys because y'all are like, what's Star Trek? Okay. All right. So let's recap. So next time we're going to be working at more challenging problems and analyzing graphs. We're going to be answering more specific questions. So it's really important that you go through this. As you go through this lesson, you know why you're answering your answer. Does that make sense? Know why you're choosing one thing over another thing. Okay, be very careful about it. Right? And I don't know why I'm not getting any next going on. Hold on. If that's the last one, I guess that's why. Okay. So, all right. And please don't ever do whatever it is she's doing. Okay, so I'm gonna make your assignment. You work on your Education Perfect. If